morning. He's like, oh, looking at my, he's looking at my monitor, making sure when the picture came up so he knew exactly when to greet you guys. Good morning. So today is day 8. We're doing verifying inverses with composition of functions. What? So we're going to be given two functions, and we've got to decide whether they're inverses of each other. And in order to do that, we're going to do something called the composition of functions. Before we can do that, we got to figure out what that is. So let's start today off with a bit of vocabulary and a definition. Composition of functions is our vocabulary word today. And what composition of functions is take one function and stick it in another. That is totally not like the technical definition of that. But I think it gets at the heart of what a composition actually does. It takes one function and it shoves it to the other one. That's all it does. It's written this way. F, little circle, G, parentheses X. That's how it's written, okay? And on your review, you'll find some of these, if you'll open your reviews when you get a chance, to page 2 down here at the bottom.
It says fog, jog,
yeah, it
farce.
looks like it says fog and jog and stuff. But that O,
F of A.
really, like, we did just push the letter O on our keyboard when we typed this up. But that's supposed to be the little circle for composition, okay? So that does not really say fog. It says F compose G. And so when we're looking at composition of functions, we say it as F compose G of X. And so that little circle is the word compose. And what this means is take G and stick it in F. Okay? And so that's what we're going to do. I'm going to use, from your review, the F function from that section, and then the G function from that section. Okay? And so this is from your Unit 9 review, and this is question number 15. What we have written on question number 15 is F compose G. And what it means is everywhere we see an X in the F of X function, we are going to shove all of the G of X function. Okay? So here's the F of X function. And now I'm going to grab the G of X function, and I'm going to stick it right there. So F compose G of X is the F function, but in place of the X,
You replace it with G of X.
I replaced it with the entire function G of X. Okay? And now I'm going to, this should feel a lot like algebraic transformations, by the way. And if it does, surprise! We've been doing compositions this whole time without me telling you and freaking you out. All right, so I'm just going to simplify this down then and see what happens.
So it depends, like, the way you write it, it depends on how the letters are placed.
Mm-hmm.
Like J-O-G.
Mm-hmm. Yeah, we'll do the next example where we'll do it the other, we'll flip them.
Oh, okay.
Okay? Because I wrote that I'm going to be multiplying 2 times 1/2. And I wanted to show you why I'm about to write it as just 1x. And it's because the whole number 2 can be written as 2 over 1. Feel free to skip whatever algebra steps you don't need. I am, for sake of instruction, writing them all out for you in many cases. All right, so there's what the composition F composed G of X looks like. For comparison's sake, because that already came up as a question, the order that you write the letters of when you're composing is important. Because let's go in and let's look at number 19, which is G compose F of X. So now I'm going to take my G function, and everywhere I see an X, I'm going to stick the F function.
Bless you.
Bless you. All right, so the order that you write the functions need to be composed in matters. Because in the first one we took G and shoved it into X, and in the second one we took F and shoved it into G.
So it's not x equals.
It's not X equals, it's that composition F compose G of X equals stuff. Or G compose F of X equals stuff. Yeah. Now the whole point of today was to verify if functions were inverses of each other. So in order to do that, to verify if functions are inverses of each other, there's only one thing you have to do. Compose them into each other. Okay, 2 things. Compose them into each other and look for equals X. If, when you're done doing all of this mess that we just did with 15 and 19, if I had gotten equals X, inverse. I didn't get equals X, not an inverse. Okay? So if you'll scooch.
So it just has to be X by itself.
All by itself. Nothing else around it. Nothing adding, nothing subtracting, no multiplication, no
The
division.
X minus 6 and the X minus 3, they're not inverse?
They're not inverses. These two not inverses of each other.
Oh, okay.
Because I don't have an X by itself right here.
So if you added another +6 and +3, that would cancel it out?
Yeah, if I did some other things to it in order, yes, I could force it to be that way. Let's show an example of one that is an inverse, okay? This is coming from your day 8, the one that you took a picture of because I ran out of paper. The question for all of the items on day 8 that you're answering is, are these inverses? Okay? So for example number 2, on the one that is currently on your phone, and if you don't have a phone after this, let me know. I'll be happy to give you. I've got a few copies that I can give you. I don't have many, but I have a few. So this is example 2 from the one I asked you to take a picture of. Here are the 2 functions that we've been given. And the question that we're asking is, are they inverses? Looking at them, I don't know. I don't know. But if I compose them into each other, and when I'm done simplifying, I get an equals X, they're inverses. So that's what I'm going to do. I'm going to do first F compose G, and then I'm going to do G compose F. And I'm just going to see what happens. All right, so here's F compose G. And then this is G compose F. Okay. I'm going to do first the F compose G, and then I'll turn around and do the G compose F. Let's race. Feel free to kind of like nose down and just kind of crunch through it and take a look up when you're ready to check to make sure I did it right. I have been adding and multiplying wrong all morning, so please. And not like purposefully multiplying wrong to see if y'all are paying attention. No, like just, I wasn't even talking while I was doing it. There's no excuse.
Couple of brain farts here and there.
My goodness. It was bad.
Miss,
Mm-hmm.
I have a question on the radio.
I have an answer.
Did you mean to write on the thingy? On the
Did I
line?
mean to write? Yes.
Oh, okay, because like someone wrote on my paper and they helped me. Thank you.
No, that was my friend, and we meant to do that. All right, so I'm looking at G compose F, the one on the right, and I'm going to go ahead and do some reducing right now because I don't feel like doing all that multiplication. I see that I have 2 over 4. 2 over 4 reduces to 1/2. So I have 2x plus 8 over 2, that minus 4.
X plus 4. No.
The 2's cancel, but I can't cancel here without affecting the 8 because it's addition. So I'm going to factor up here.
They're inverses.
Okay, I'm going to pause here for a second and ask between lines 3 and 4, are there any questions on how I went from line 3 to line 4? Yes. Okay, so I'm going to scoot this over. What I did was I factored at line 3. So I took this value that was my numerator, and I looked at what do I need to multiply to give me 2x? 2 times 2. What do I need to multiply to give me positive 8? 2 times 4. The 2's are what they have in common, and so I can write that out as a common factor, and in parentheses, I write whatever is left over once I ignore that common factor. Okay? So I factored that top piece. And I factored that top piece because now I have 2 over 2, which can cancel. And now those 4's cancel. And I have equals x. All right, so here, because I shoved x into G, f into G, I can state that f of x is the inverse of G. And on the previous one, when I shoved G into x, it lets me say that G is the inverse of f. And so your final answer is yes. They are inverses. So this is the final answer that gets boxed in. And all the rest of what we just did, all of that is the justification. Questions?
Cause like we the third one, like I kind of like in
This
my
one?
brain, like I kind of thought what to do. Like we could have like divided,
Yeah.
and then it would have been x plus 8 minus 4, I think. No, 8x minus 4. Or I don't know. No, you also divide the 8, so it'll be
Yeah. So it would be this line.
yes.
Yeah, that you can do it in your brain kind of trips me out, and it's amazing. It's awesome. So I'd like you to just write down as much of that as you need,
Yeah,
so
like I kind
that,
of understood it at 3, or like I
Good.
didn't know what you did at 4. Like I just got lost.
okay, I factored, I did this.
Oh, okay.
I did what you did, but I wrote out why I did it.
Oh, okay.
I did it without factoring.
You did it without factoring. Okay, so you divided the 2 into the 2x and into the 8?
Like, I worked it out, like, I did, instead of doing what you did, and getting rid of the 2s and the 4s, I had just wrote it out, like, I multiplied the 2 times the top half. And
Okay. Oh, but not by the bottom. You can't multiply this 2 to the bottom because that 2 is essentially 2 over 1. Now you're multiplying fractions, and top times top and bottom times bottom. The bottom of that fraction is a 1.
I don't know what I did, but I ended up getting it
With the same way. Okay, I'll take a look at it. And
because it ended up at the end being 2 divided by 4 over 8, and then it worked out to
8.
being 1.
okay, I'll take a look at it.
Somehow.
You may have done new math. I'll take a look. I'll take a look. What was the other question? Someone else had a question over here, and I was like, you answered it for yourself already. Good. In asking it out loud, you answered it. I love it. Any other questions? That's it. That's all I had. Thank you very much.
Bye.